Hi everyone. In this video, we will discuss a lot of topics regarding the Model Context Protocol and the agents. So the Model Context Protocol provides a standardized way to connect large language models to tools and data. And in this video, we will be using fastMCP library, where fastMCP is a standard framework for building MCP applications. MCP became very famous about a year ago, first introduced by Anthropic. So first we will discuss why Model Context Protocol appeared and what benefit it brings. And then our story will be aligned with the following venue. Throughout this video, we would like to build a multi-layer architecture. So at the very bottom of this architecture, we will have a backend system or API endpoint. Then we will have MCP server as a middleware, and MCP server will be implemented using fastMCP library. Then on the front-end layer, we will have MCP Client and two agents, AWS Strands Agent and ADK Agent. So I will separately develop simple MCP Client Python script, and then we will have a look at more complicated AWS Strands Agent and ADK Agent. So first, I will design the API endpoint, and for this purpose, I will be using Fast API. Next, I will create MCP server to make calls to the API endpoint, then create AWS Strands Agent, and finally create ADK Agent. So on this stage, we will be using the following setup. I will use the localhost port 8000 to deploy Forex API endpoint, and I will use localhost port 8001 to deploy Forex MCP server, which will make calls to the Forex API. Then we will do another extension, and actually we will deploy MCP Proxy Server using fastMCP in front of the Forex MCP server. And Proxy Server will be deployed at localhost port 803. So then we will do some extension to our original setup. So I will create a script to use Weather API endpoint by National Weather Service. In this particular case, Weather API is deployed on a National Weather Service server. So this will be a remote server. Then I will create a Weather MCP server, which is calling Weather API endpoint by National Weather Service. And finally, I will connect Weather MCP server to MCP Proxy Server. So MCP Proxy Server will be at this point connected to Forex MCP server and Weather MCP server. And then we will update MCP Client, AWS Strands Agent, and ADK Agent. Finally, so the architecture setup for this particular implementation will be having the weather server deployed at localhost port 8002, and original Weather API is located at https api.weather.gov. So finally, I will do one more modification. I will add Fast API Search MCP server, which is available at https gofastmcp.com/mcp, and I will connect that MCP server directly to the MCP Proxy Server. So this is example of remotely deployed MCP server provisioned by fastMCP team. And finally, we will have a look again how the MCP client is recalling the list of tools and how agents interact with the proxy server. So before we go into the coding, let me briefly explain the origins and reasons for Model Context Protocol to appear. So in my previous video, I have already provided this simple outlook of the agent. Agent basically is a wrapper around LLM and tools. While LLM is doing text generation and reasoning, the tools are actually the methods for the agent to reach the outside world and do some operations. But it is LLM to decide which tool to invoke according to the client request or user request. So to be more specific, for the agent, we will have a large language model, and we will have a set of tools. So for example, we can have a weather tool, we can have a Forex tool, we can have some calculator tools. And in this particular case, it is very important to understand how large language model is selecting tools. So once the prompt from the user arrives to the agent, the large language model analyzes that tool. And once LLM has done its reasoning and understand that this particular request is, for example, to know the weather forecast or current weather at a particular location, then large language model will need to select a weather tool. So how the tool is selected? Without MCP, once we define a tool as a Python function, we will have to provide a docstring description. So the large language model will have a look at the function name, which is used as a tool, and the description from the docstring. This is how a large language model is selecting the tool itself. Now let me introduce the key components of the MCP. So MCP requires basically three components. MCP host, which is an application, and MCP server, which is a server provisioning the set of tools. In case of fastMCP, also resources and prompts can be shared as long as the tools. But in this video, we only concentrate on the tools. And these tools being available to the MCP host by means of using MCP Client. So this is the crosstalk between the MCP Client and the tools. So why MCP protocol has emerged? Imagine a situation that we have two different agents, and this agent can be implemented in very different SDKs. So for example, one can be AWS Strands, another agent can be ADK or LangGraph agent, and this will require a little bit different development of the agents themselves. Especially in the case of LangChain and LangGraph agents, the way we define the tool will have a significant difference, how the tools are actually defined in ADK and AWS Strands. So the question is, if we are to use similar tools in the agents, but if tools are overlapping, how now can we efficiently run the tool versioning, maintenance, and so on? So the one solution for that will be having a centralized repository and review the tools. However, as I mentioned, different agent SDK might require different ways of integration with tools which may not be compatible. So we will have to have multiple versions of the same tool for various SDKs, which is not really convenient. And here's exactly where MCP comes into picture. So MCP server is deploying the tools and making them available remotely. So now, instead of directly storing the tools inside the agent or calling some external libraries which contain the tools, we simply put MCP client in the tool section of the agents. And this is how we can now outsource the tools to a remote server. And as I mentioned, this is exactly the architecture. So now in case of MCP host, we will have our agent, and MCP client will be placed inside of the tools. It is very important to mention that there are two transport types which are now available for the fastMCP. So the first one is standard I/O operations. Basically, this is standard I/O streams. For this, if you are to use standard I/O transport, you are only limited to have MCP server and MCP host in the same machine, or basically in the same environment or in the same operation system. So this is maybe good for debugging and just setting up quickly and test the ideas, but of course this is absolutely not the way to go for scalability and to production. So the second transport is a streamable HTTP transport type. In this video, I will be using streamable HTTP transport type for all the HTTP servers and for all the agents consuming those servers. So let me summarize. We have already mentioned that once the input and context reach the agent, LLM will have to do the reasoning, and if the input and context contain any request for some action, this action will be realized, and if there is a corresponding tool, the corresponding tool will be selected. So once this tool is selected, LLM will also extract necessary inputs for that tool call, and from this point, the tool will be executed. Once the tool is executed, the result returns back to large language model, and large language model generates the final response of the agent. So the model context protocol is basically taking the burden of the communication of large language models with remote tools, selecting the tools and executing the tools, and returning these to the agent large language model. So this is the main value of the MCP protocol, and this is the main reason why we become to have a need for a new protocol, because there is a heavy exchange between large language model and the tool as per tool selection, because we are using the docstring and tool name to identify what is a reasonable tool to apply in this case, and then model and then the tool execution, of course, once the tool is selected. So in general case, the architecture should look like this. So we will have two or more agents, which will be talking to the MCP server. The MCP server can provision multiple tools like weather tool, Forex tool, calculator tool, or some CRM tool, and then we should speak to some CRM system application. In our case, instead of CRM tools, we will have our homemade Forex API, which is implemented using fastAPI. Then I will use a Weather API endpoint by National Weather Service. Okay, having this understanding, let us finally start coding. So now let's design our fastAPI for Forex inquiries. So the idea is that I have a JSON file which contains a cross rate for three major currencies: USD, EUR, and GBP. And this is basically 3x3 metrics by showing each possible case, by showing each possible combinations. So our API will be reading this JSON file, and this is the load rate function, which is basically reading the JSON file. And then I will deploy the endpoint located at rate, and then additional parameters with base currency and target currency. So we will have to make a GET request to this location. And I will call this function get cross rate. So the inputs will be base currency and target currency. So this will be just a simple preprocessing to put the uppercases. Then we will load the JSON file. And then we will check if the base currency is in the list of available currencies. So if not, we just raise exception. If the base currency is in our list, basically inside the JSON object or inside our dictionary, once we load the JSON file into the Python script, we will have JSON structure being available as a dictionary structure. So essentially the keys of that dictionary will be the base currencies. So if the base currency is not on the list of keys, then we simply don't have that currency. And if we find the currency in the list of keys, then we will get their target value. Because in this case, the JSON file will be translated into the nested dictionary or nested hash map structure. And then we will return base, target, and the cross rate between these two currencies. So this is simple API. So we will go ahead and deploy this API using Uvicorn. And as I mentioned in the previous setup, that we will be using port 8000 for our API. Okay, so API has been successfully deployed. Now it's available at port 8000. Let me show the docs. And you can see that indeed the API is deployed successfully. And now let me try to run the query. So I will use the USD as a base and GBP as a target currency. So this is our cross rate, which we have extracted from the JSON file. Now, how can we create the MCP tool which will be calling this API? So the basic schema is to define the fastMCP and then define a tool using mcp.tool decorator, and then we can run our MCP server. So let me show you the implementation for Forex MCP server. So first of all, we input fastMCP as our MCP library, and we define MCP equal fastMCP. So here we define our MCP server and we call it Forex MCP server. Now we will enable the tool which is querying the API which we have previously deployed. So to mark the Python function as an MCP tool, we use mcp.tool decorator. And as in the case of tools which are provisioned directly within the agent code, we also have to provide the doc string, which will be the landing for LLM to select whether this particular tool is the one which corresponds to a current request or not. Now we will use the request class, and in our case, I provide the API URL like this, where our base and target will be the inputs of the tool. And then we simply issue the GET request to the URL, which is our local host and which is successfully deployed. And once we get the success status code, which is 200, we will get the JSON response, and then we will return this JSON value. Otherwise, we will say that data is none, and we will return that dictionary as a tool response. And finally, in the main section, here we will run our MCP server. As I mentioned, we will be using transport type HTTP everywhere. We will deploy our MCP at the same local host, so providing all zeros for the IP address, and we will deploy it at port 8001. So let me go ahead and deploy our MCP server. In this case, deployment can be done through the direct Python execution. Okay. Now we can see that our Forex MCP server is successfully deployed and available at localhost port 8001. And now let's do the testing. So at this point, let me create a simple client. So I will import a client class from fastMCP library. And as we have selected Streamable HTTP is our transport type, I will import also Streamable HTTP transport from fastMCP client transports. And I also will use async IO. So in this particular case, I have already deployed the Forex MCP server at localhost 8001. And to get actual MCP response from that server, we will need to use MCP routing. And this is true basically for all the MCP servers. So now let me write the main function. So it will be a synchronous call on the main function. First, we will define our transport. This is our streamable HTTP transport. And in this case, I don't have proxy server deployed yet, so I will be using our Forex MCP server. Now I make this transport available to the client. So this client is exactly corresponding to MCP Client, which I have been explaining earlier in the MCP architecture. And then we will do a synchronous call with the client. And so first we will get the list of the tools. And we will process the list of the tools. We will just get the list of the names from the server and just print it out. And then I will use the cross-currency rate, which is exactly the tool name in our Forex MCP server. So I will use this cross-currency rate tool, and I will explicitly provide necessary pair of currencies. And then I will return the results and see what is the structured result of that. So basically, we will not provide any prompts explicitly here. So let me run this MCP client. Okay, so that was quick. And we can see that there is one tool available on the MCP server, which is cross-currency rate. This is the raw response, which has been provided by the tool. And then within the raw result, there is a structured content section, and this is the structured content. So far, we have the same confirmation as we have seen. So far, we can see that this is the same as we invoked API directly. So at this point, we have completed our 3 steps. So we have deployed Forex API, we have deployed MCP server, which is involved in Forex API, and we have created MCP client, which is capable of talking to MCP server and calling MCP tools and reaching the API endpoint through the MCP server. Now, let us design AWS Strands agent. So to import the agent, I will use Strands library itself. I will also import MCP client class from Strands tools MCP. And from MCP library itself, I will use a client streamable HTTP, and I will use a streamable HTTP client. So here I will define a streamable HTTP MCP client, which will be our MCP client from Strands tools MCP. And I will provide streamable HTTP client as a reference to our server. So in our case, this will be our Forex server. And now I will define the agent. So first of all, we will provide a context of streamable HTTP MCP client. Then I will define tools as streamable HTTP MCP client tools list. So now we will see the tools list, and now agent will be able to deal with the tools which are available at this MCP server, which is our Forex MCP server. Then we define our agent and define the tools for the agent. And finally, we will do a query to our agent. What is a cross rate for USD GBP pair? So let's go ahead and run this code. Okay, so the IDE is saying that this streamable HTTP client is actually deprecated, but once I tried changing these to the suggested new class name, I got the error. So we are basically using the streamable HTTP underscore client class directly without any updates for the non-deprecated one. And now let me try to run Strands Agent. So we can see that Strands Agent has identified cross-currency rate tool and has provided the request of USD and GBP pair. And here is our cross-currency rate and some more description about the USD and GBP pair. In this case, we were able to use MCP tools deployed in our Forex MCP server in the agent. So now let's do the same for the Google ADK agent. So for Google ADK agent, I will import agent from Google ADK agents. I will use the special class MCP toolset from Google ADK tools MCP toolset. And I will also use Streamable HTTP connection parameters from Google ADK tools MCP tool MCP session manager. And here I already prepared a number of URLs for various MCP servers. So first we will use Forex MCP server URL. And at this point, I will only create a single MCP toolset where we directly make a call to Forex MCP server, while I will keep remaining toolsets commented out. In this section of the code, I define the agent. That's a peculiarity of ADK, that if you are to use ADK web, which we are going to deploy now, the agent name given to the agent should be the same name as the directory where this agent resides in. Then we provide Gemini 2.0 Flash model. We describe this to be a tool agent. And finally, we are instructing the agent that you are a helpful assistant that can use various tools. And for this particular case, I will be using Forex MCP toolset, which is our connection to Forex MCP server, which we have already deployed. So as I mentioned, to run ADK agent, I will need to use ADK web UI. And for ADK web, I also need to define the port. So let me deploy ADK web at port 8010. And just give a few moments for the UI to be deployed. Okay, now we have our UI available, and this is our agent. So we have a tool agent, and now let me ask the same question: what is a cross rate between USD and GBP? Now we can see that ADK agent has invoked cross-currency rate tool. It completed the tool execution and returns the result as current exchange rate is 1 USD for 0.75 GBP, which is again a correct result. So at this point, we are able to complete these 5 steps. So let me quickly summarize. I have deployed a custom Forex API using fastAPI. Then I have created MCP tool and deployed with MCP server. Then I have created MCP tool to invoke API endpoint, and I deployed that MCP tool with MCP server. Then I have designed a Python code for MCP Client. I have designed a Python code for AWS Strands agent, and I have designed ADK agent. For the details of AWS Strands agent and ADK agent, please follow my videos. I have already deployed a few videos about AWS Strands agent, especially which LLMs are used there, because once I was showing you code for ADK agent, I explicitly showed the Gemini model, but in case of AWS Strands agent, I haven't provided any model there. So you can get the details of how AWS Strands agents are developed and how to define the models there. There will be links to this video in the description, and also you will see the video card here in the video itself. So far we have completed these 5 steps, and this is the setup. We have our API endpoint at port 8000, we have our Forex MCP server at port 8001. I also used ADK web which has been deployed at port 8010. Now let us do the next step, and let me introduce the MCP Proxy Server. So the proxy server is basically used as a front-end server instead of backend server, and it can serve various purposes. So how can we use fastMCP to deploy a proxy MCP server rather than just a standalone server? Let us have a look. So here is the code to deploy MCP Proxy Server. So first, as usual, I will import fastMCP from fastMCP, and then I will import proxy client from fastMCP server proxy. First, I will define the backend variable, which will be our proxy client. In this case, our proxy client is reaching out to our Forex MCP server, which we have deployed at port 8001. And here I'm putting the sampling handler to none. What is this sampling? Recently, this LLM sampling is a very big story. In short, LLM sampling allows the MCP tools to use LLMs of the agents. And this is, of course, a very big and complicated topic, and I will have a separate video on that. And this is very, very new feature, and almost none of the MCP clients are supporting that. But in the future, there are big plans for this particular LLM sampling idea. Now, when I have my proxy client, which I call the backend, I can now define my MCP server as a proxy. So I'm not defining any MCP tools directly in this proxy server, but I will use my backend, provide a name as proxy server for Forex MCP. And finally, I will run MCP server with the transport type HTTP, run it on localhost on port 8003. So let me go ahead and deploy MCP Proxy Server. Our proxy server for Forex MCP server has been successfully deployed at localhost port 8003. And now let me do a slight modification to the client code. So instead of MCP URL, I will be using now proxy URL, which I have already predefined. So I'll just change the variable name here. And it looks like so far this is the only change. So let me go ahead and run this client without any changes, and we will see what will happen. So now we will be calling not MCP server directly, but we will call MCP proxy, which is standing in front of our originally deployed MCP server. So let me run the client again. Okay, that works. And in this case, we are directly acquiring our MCP proxy server rather than directly MCP server. Of course, deploying proxy server just for one server is maybe not so reasonable until and unless you want to really redirect or make the server which is behind the proxy server available through the proxy server for some reason. But usually proxy servers are connected to multiple servers behind them. And now let us design a new MCP server, and we will connect that MCP server to our MCP proxy server. So I would like to do a tool which will be providing a current weather condition at a particular location in a particular city. And for this, let me first go you through the code just to do that particular operation. Let me guide you through the code to get the current weather conditions for a particular city. First, I will need to import a requests, and here I will use a Google map. Particularly, I will import the Google Map client and I will call it Google Maps. Then I will need OS and .environment. The .environment library, I will use load_.env function. Basically, I will use .env file, which will contain my API key for the Google Maps. And this is why I need to load that as an environment variable. So this code consists of two main things. So as I mentioned, I will use National Weather Service API. So you can find the description of National Weather Service API description here at this location. In particular, I will be using this /points/latitude endpoint, which is providing a particular weather condition at this geolocation. However, I will be inputting a city name as original input, not the coordinates. So I will need a helper function, which I called getCity latitude and longitude. This helper function will actually convert a city name into coordinates of the city. So I will return latitude and longitude of the city, and these coordinates will be then provided to the Weather API. Also, Weather API is not that straightforward. So first of all, I will get the physical coordinates of the city. Then I will get the reference point from the first API endpoint. Then I will have to do some manipulation with that API, and I will get the URL for the current weather for the given coordinates. And then, given that URL, I will do another HTTP request in order to get weather condition at that particular geolocation. And having that, I will return temperature, conditions, wind, forecast. So the city will be provided as an input argument, and then I invoke this function. So let me go ahead and run this. Okay, I will input Irvine, California. This script returns 64 degrees Fahrenheit, cloudy, wind is 5 miles per hour southwest, and there is no forecast here. Okay, so this script works. Now, let me convert these functions into the MCP tools and deploy Weather MCP server. So let's go through the code. So first I need fastMCP library, the requests, Google Maps, OS, and .env, from where I will be using load.env to get my environment variables, more specifically Google Maps API key. So I will copy this function as is from the previous code, and this will be my function to convert city name into geocoordinates. Just remove unnecessary comments. Now, as in the previous case, I will apply mcp.tool decorator to get current weather function, and I will slightly modify this later part of this function. So now I am returning a string instead of just printing out the results. And because we actually have this function which is converting a city name into geocoordinates, I will also provision another MCP tool, and I call it getCityGeo, to actually return geocoordinates of a given city. One important notice here is that, so once you provide MCP tools decorator here for the helper function, that function will be no longer eligible to be called by the tool, and it will actually crash your server. So that's why, in order to provision this city name to geocoordinate tool, I am just making a wrapper around this helper function. So let me now deploy. Weather MCP server. So now this server is available at port 8002. Now let's update our proxy server definition. So previously we used proxy server just to enable access to a single MCP server behind it. However, at this point we would like to provision multiple MCP servers, and for this task the proxy client architecture doesn't work anymore. So we will have to define MCP server config, providing the MCP servers behind it and explicitly stating which transport is used to communicate with that particular MCP server. So currently we have provisioned Forex API MCP server. We have just provisioned Weather MCP server. And this is MCP server, which is provisioned by fastMCP server itself. So this is remote MCP server. We simply don't have to do anything to deploy it. We can just use the URL. This way, we will expose the server and all the MCP tools which are available at that server. So I will do some tests just in a few moments later. For now, let us go ahead and deploy our MCP server using the config. So instead of provisioning the proxy client, now we are providing a config, and we are going to run our proxy MCP server at port 8003. So let me stop the previous proxy server, and now let me deploy proxy MCP server which has access to multiple MCP servers. Okay, it is available at port 8003. So at first, let me try to use the client. So now let me update the client, because previously we were using directly MCP server. Now let me use MCP Proxy Server. Everything else stays the same, and I will not modify this line either. So let me go ahead and run the code. So previously we have seen only one tool, which was cross-current rate. Now we see all the tools which are available from multiple, in our case it's 3 MCP servers. However, you can see that the names of the tools has changed as well. So in this case, the cross-current rate tool name has been updated to Forex API cross rate, and get current weather and get CTGeo tool names, which were defined originally like this once we were deploying Weather MCP server, they are now coming with weather forecast prefixes. So basically, once we deploy proxy server, the proxy server is adding prefixes of the server names which we provide in the config. So here, so this is our Forex API. This is the prefix has been added to our original tool name. This is the weather focused prefix which has been added to two tools which we defined in the original MCP server. And then this is a search fastMCP docs. So this is our prefix. And then this is search fastMCP, which is a tool provided out of the box on the remote MCP server by fastMCP team. And here we have error. And basically the error says unknown tool, because in our client, I was calling the tool cross-current rate by its old name once I only had a single MCP server available. But now, when I do have a number of servers behind the proxy server and proxy server is adding the prefixes, I will have to update this code and I need to change a different tool name. So basically I will have to add Forex API prefix underscore to the original name of cross-currency rate. So I will have to add prefix Forex underscore API underscore to cross-currency rate, which was original name of the tool. So let's save the code and run the client again. So since this is a multi-layer server, so first we go in through the proxy server, then we actually call in the backend server. There is essential overhead now, and the time to generate the true response is becoming longer. This is also very important factor to consider. But finally, we got our correct response from the tool in the same way we had it in the case then we have just deployed a single MCP server. Now, let me do the updates to the agents, and we can test various MCP tools. So let me take a new code for the Strands agent. So originally, the Strands agent, we were using a single server. So I have modified the code of original Strands agent a little bit. So now I am providing a required parameter to the console call, and this parameter will be query. So I'm using this query as actually query for the agent. So this way I will be able to provide a query of interest as a part of the command line call. And now I have already the URL updated for and the rest of the code is staying the same. So let me clear the screen and run the Strands agent. Okay. And now Strands agent says you forgot a query, which is basically expected. And since I can provide any query I want, so let me ask the agent, what is current weather in New York State? So the Strands agent picks up weather forecast to get current weather. Okay, and we have a successful response of temperature of being 38 degrees Fahrenheit, partly sunny, and wind of 17 miles per hour west. So let me ask another question. What are geo coordinates of New York City? Okay, now agent is capable of successfully identifying weather forecast get city geo. Okay, and this is a response of latitude and longitude. All right, so we have few more tools. Basically, let me now ask our original query, what is a cross rate for USD GBP pair? So we will make sure that our Forex queries work successfully. Okay, so the agent is capable of identifying Forex API cross-currency rate. Okay, and the result is also successful. Plus, agent's LLM is providing some additional information. And finally, I have also connected fastMCP document search server to my proxy server. So now I will be able to search for the fastMCP documentation. So let me go ahead and run that query. So I will ask, what is fastMCP Proxy Server? Okay, and now we can see that there is a search fastMCP tool being invoked, and there is a crosstalk right now with the MCP server deployed by fastMCP team for the fastMCP documentation search. Okay, and now you can see that the agent provided very elaborated response to our question. So this basically shows that we were able to successfully deploy the proxy MCP server, which is having 3 MCP servers in that backend at this point, and all the tools are now available. So in the next step, let's check whether our ADK agent is capable of doing the same. Okay, so now let's update our ADK agent to be able to communicate with proxy MCP server. But before they actually do that, I want to show a different way of connecting multiple MCP servers directly to the agent. So in our previous case, we used MCP toolset to connect to our Forex MCP server. So now let me define the toolset. So now let me define the MCP toolset for our Weather MCP server. And I will now use both toolsets in the tools for the agent. So let me redeploy ADK Web. And now let's test our agent. So ADK Web is deployed at port 8010 as expected. So let me refresh the tools agent, and let me ask again, what is the cross rate for USD GBP pair? And remember, in this case, I have only connected our agent to Weather MCP server and Forex MCP server. So the tool to search fastMCP documentation is not available at this point. And as you can see, the cross rate function works. So we have identified cross-currency rate and executed cross-currency rate tool, and we get the same result as we had previously. Important thing is that tool name doesn't change. This is because we provide different MCP servers as separate tool sets, and there is no prefixing happening to the tool names. So now let me ask, what is current weather in Irvine, California? So the agent was able to identify get current weather tool, was able to invoke the tool and get the response, and the successful response is that it's 64 degrees Fahrenheit, cloudy, and wind 5 miles per hour southwest. Now let me ask, what is geolocation of Irvine, California? So I expect to see latitude and longitude of the Irvine, California. Okay, and you can see that the agent was able to correctly identify get CD geo tool, and now providing us with latitude and longitude of Irvine in California. So in this case, you can see once we use this MCP toolset method to connect to MCP servers and use MCP tools, then the tools are actually still preserved in their original names. Now let me use MCP Proxy Server. For this purpose, I will now comment out Forex MCP toolset and Weather MCP toolset. Now let me uncomment the code, which is basically using MCP toolset for our proxy server. And I will call it Proxy MCP toolset. And now let me provide a single toolset to the ADK agent. Let me save the code and redeploy ADK web. Okay, ADK web is available. Let me refresh UI. And now let me ask, what is cross rate for USD GBP pair? And you can see that in this point, now we have a Forex _API cross currency rate tool being identified. So we can see this prefixing, and now this tool being executed. So we have a tool response. Now the LLM is generating the response. And here's the correct answer of 0.7 GBP per 1 USD. Now let me ask about the weather condition. What is weather now in Irvine, California? So you can see the weather forecast prefixing for get current weather tool, which was original name. And now this tool has been identified in accordance with our request. So it will take some time to process the tools and process the result of the tool. And here you can see which tool is now activated. So now you can see that the tool is active now, and that the tool agent has access basically to 4 tools, which is cross currency rate, get current weather, get CTGeo, and search fastMCP. So weather in the white is the same as it used to be like 5 minutes ago. So it's 64 degrees Fahrenheit, cloudy, and 5 miles per hour southwest wind. Let me ask, what is Irvine, California geolocation? So the agent has correctly identified weather _ forecast _ get CTGeo. So get CTGeo was original tool name, and weather _ forecasting is a prefix added by the proxy server. Now you can see that the tool is active, so it's basically performing the tool operation. So the tool operation is complete. Now the agent is wrapping up the results. And we have the same responses we had previously. Latitude and longitude provided. Let me ask, what is fastMCP Proxy Server? Okay, so the agent was capable to correctly identify its search fastMCP tool for our search fastMCP server. So this is MCP server, which has been remotely deployed by fastMCP team direct. So we were not required to make any efforts to provision that server. We were just providing it as a part of config of the proxy server. You can see the response. So MCP provides proxying capabilities, allowing MCP server instances to act as front end for another MCP server, and so on. So this is very detailed description, not as detailed as the one provided by Strands agent, or basically by the LLMs behind the Strands agent, but still it's capable of reaching out for a tool and extracting the information. Okay, so let me summarize. Where are we in our way? So we already have developed Forex API. We have already designed Weather API. We have already deployed Weather MCP server and Forex MCP server and the MCP Proxy Server on top of that. And we were also able to add the Fast API Search MCP server provisioned by Fast API team at this location. So we have completed our task and the plan for today's session. Okay, so this concludes our session today. We were able to complete all the steps. So I hope you enjoyed it, and follow me for more videos. There are more interesting topics to cover, like LLM sampling, LLM elicitation, and these are new features for MCP servers. So stay tuned, like and subscribe, and see you soon. Thank you.